Hello everyone, myself Dr. Jyoti Mandala. Welcome you all to the video lecture series on operating systems. We are in the process of learning different concepts under operating system. We are in our lecture number 3. Earlier to this lecture, we have learned about what actually an operating system is. We have come up with the definition of the operating system, and also we understood what are all the services that are provided by the operating system, and then we learned about the different types of operating systems, starting from serial processing system to real-time operating systems. I hope you all are clear with those concepts. Okay, so in today's class, let us see different types of memories we have. Whenever we want to store data in the computer, obviously we are going to store the data in the memory, right? Now, to store the data in the computer, what are all the different types of memories we have, and we'll see what is the hierarchy of that one. In terms of parameters like the cost, and in terms of parameters like capacity, the amount of data that can store. By considering those parameters, let us understand what are all the different types of memories we have and the hierarchy of that one also. Okay, so here mainly I am going to talk about 3 types of memories, but it is not confined like a computer system will be having only these 3 types of memories. Okay, but we'll understand first these 3 types, and I'll help you understand what are all the other types of memories also we have. Okay, so mainly we have 3 types. What are they? The first type is cache memory. Second type is we can say like it as a primary memory. Third type is we can say this one as the secondary memory. Okay, so why we need to have all these different types of memories? See, depending upon if like we need to have ensure like even if power goes also we need to want the data to be available, and also if everything is available at one place, it takes the CPU time. The CPU takes a lot of time to get the data from that memory because it has to search the complete memory. So considering all these things, we have different types of memories like cache memory, primary memory, and secondary memory. Okay, so let us see one by one what are all these memories. First, let me start with the primary memory. Primary memory is nothing but it is also called as a main memory, where in this type of memory what happens is whenever a CPU executing any program, that data should be available in the primary memory. So this memory is also called as main memory. I am writing it as MM stands for main memory. Now what is the use of this one? This main memory holds a particular data, that data where the CPU can access the data from here. So whenever you are executing, let us consider program 1, your CPU is executing program 1. That program 1 should be available in the main memory, which is called as primary memory. Until and unless it is available here, the CPU cannot execute that program. So you need to remember one point here is all the programs which your CPU is executing at that particular time should be available. Suppose if it is not available, then it has to be brought into this primary memory, then only it can be executed. So we have main memories like RAM, ROM. Let us not go in detail about all those things, but you need to understand our RAM is nothing but random access memory, and we have the other type ROM. ROM is nothing but read-only memory. Okay, so these 2 types are called as primary memories. I hope you all are clear. So currently executing program, whatever CPU is executing, that program should be available in the primary memory. And one more important point here you need to understand here is it is volatile. Volatile is nothing but once whatever data you have stored in this memory, that will be erased once the system is off. Like once the power is off, whatever data is available in the primary memory, it cannot be restored back. So that is what volatile means. That means it is not a permanent memory. The data that cannot be stored permanently in the primary memory. Right? Now let us see the second type of memory. Let me talk about this secondary memory. Secondary memory is nothing but your hard disk. One example to this one is hard disk. Now what type of data will be stored? This is called as a hard disk. Now all the things, whatever information, the programs and its related data, everything we are going to store in the hard disk. Now why we need to have a hard disk? This hard disk is called as a non-volatile. What do you mean by non-volatile? It is nothing but it is a permanent data. permanently it will be storing the data. What do you mean by that one? Even if you switch off the power, even if the computer is off, the data should, the data will not be erased in the secondary memory. So you need to understand hard disk. The data that is stored in the hard disk is available permanently. Until and unless you delete that one, it will not be deleted. Right. Now here in the secondary memory, what actually happens is all the programs and data will be stored in the secondary memory only. But whenever a CPU wants to execute anything, then that particular program should be copied from the secondary memory to the primary memory. Then only the CPU will be executing the things. I hope you are clear now. Right. Now coming to the third type of memory, what is this third type of memory is, because the primary memory may be holding some data, but to reduce the amount of time the CPU requires to for a particular data, then instead of keep on checking in the primary memory, that data can be stored in the cache memory. Okay, so we can say cache memory is nothing but frequently, if something is required by the CPU, frequently required data can be stored in the cache memory. Okay, so frequently requested data can be stored in the frequently whatever data you want to use, no, that can be stored in the cache memory. So considering those requirements, we have these three types of memory. Cache memory is available in the processor itself. Okay, here you need to understand. Let us consider, I'll show you one simple example. Let us consider here. Okay, so if this is the CPU, okay, and then if the CPU want to execute anything, no, it will be first checking in the cache memory. So you will be having a cache memory. Okay, after that cache memory, you will be having the other type that is called as a main memory. Or you can let me write like personal primary memory. After primary memory, we will be having the secondary memory. Okay, that means you need to understand here. You will have a CPU, and then you will have a cache memory, and then you will have a primary memory, and then you have a secondary memory. Okay, now whenever CPU is executing any program, it will be first checking the data in the cache memory. How from where the cache memory will be getting the data? The cache memory will get the data from the primary memory. Okay, and then the primary memory, if it wants to get the data, it will be accessing the secondary memory. Now once the program execution is done, then it will be stored back into the secondary memory, and next program whatever you want to execute, that can be stored here. So we can say it is bidirectional. We can say like this. Bidirectional, this way, this way. So the primary memory will be getting the data from here, and once the execution is done, it will be stored back into the secondary memory. Why? Because I already told you secondary memory is a non-volatile. Okay, this is the way how CPU can be accessing the data. Now why we need to have cache memory? Because frequently data whatever we want to access, that should be available here. Now here you need to understand the cache memory is of high speed, like the amount of time that is required to access, like CPU whenever it wants to get any data, it can access, the CPU can access the primary memory also. Okay, but the time required to get the data from the primary memory is less when compared to the when we are getting the data from the cache memory. So what they are going to do is frequently requesting data. Let us consider we want to use a variable A in our program, and this variable A we keep on using this variable A. Then instead of storing that variable A in the primary memory, we can store that variable A in the cache memory. Why? Because it is frequently used. Understood? So that we can reduce the amount of time to get the value. But whenever we are talking about the size requirement, then the size of the cache memory will be less than compared to the primary memory, and the size of primary memory is less than compared to the secondary memory. Why? Because secondary memory will be holding a lot of data. Everything whatever is there, we want to store, that will be stored in the hard disk. But the limited data, limited programs and its related data, whatever we want to execute, that should be stored in the primary memory. So when compared to the secondary memory, the primary memory size will be less. But and also coming to the cache memory, only frequently used data we want to store. So compared to the primary memory size, the cache memory size is very less. Here I'll show you one diagram. You all can go through this diagram. You can see here I have represented other types of memories also here. You can see we understood about cache memory, right? This is what we understood. So this is the cache memory. Let us consider here is the CPU. Okay, CPU is available here. Now how it is going to access? CPU is nothing but your processor which is executing your program. Now coming to the memories, we have cache memory, we have main memory, and we have the hard disks, electronic disks, or whatever the other types of memories. Okay, so observe here the hierarchy. This represents the rectangular box, whatever I am representing here, that represents the size. So you need to understand the main memory size is less when compared to the secondary memory size, and the cache memory size is less when compared to the main memory size. So you can say in this order, if I am telling, let us consider in this order from top to bottom, if I want to represent, no, then in this order the size of the memory decreases. Size decreases. But if you are talking about the speed, let us consider the amount of time required to get the data from a particular register. Registers are nothing but like these are also limited storage, okay, which will be available in the CPU. Okay, registers are also available in the CPU, which are used to store limited data. We will be having 16-bit register, 32-bit register, like that. It depends upon the configuration. Okay, so all these things, whatever we say, no, if you talk about the size reduces from bottom to top. But if you are talking about the speed, then the amount of time required to access the data by the CPU from the registers is less when compared to the cache memory, when compared to the main memory, when compared to the secondary memory storage. So you need to understand speed. Whenever we are talking about speed, no, speed increases. Speed increases in the sense the amount of time required to access will be less. Okay, and coming to the next one more parameter, that is about cost. What is the cost parameter if you are talking? So the cost of cache memory is more when compared to the cost of main memory, and the cost of main memory is more when compared to the cost of secondary memory. That means cost also increases. In which direction? From bottom to top. So the cost of these memories is cheaper when compared to the cost of main memory, like that. I hope you all are following. Right, so this is how the memory hierarchy is considered. So storage access time will be decreased. That also we can consider as one parameter, access time. Okay, access time will be decreasing. Okay, so let me show you some comparisons here. I have taken 4 levels. First level is register, second level is cache memory, and the next one is main memory, and the next one is the disk storage, which is our hard disk. So typical size will be less than 1 KB. I told you, no, the size will be reducing. If we are using 100 GB of disk, we will be having less amount of GB for the main memory, and we can have here it is considered as same, but obviously we require less amount of memory only because frequently data is required. Okay, and then less than 1 KB of size is required for the registers. And the implementation technology is like it uses CMOS. Okay, and this uses SRAM, and this uses DRAM, and this is magnetic disk capacity. And if you're talking about access time, no, you can see here the access time. The amount of time required to get the data from the registers is between 0.25 to 0.5. This will be little bit more when compared to the registers. This will be even more when compared to the cache memory, and this will take a lot of time when compared with between all these 4 types. Okay, and it is managed by the compiler. Registers are managed by the compiler, and cache is managed by the hardware, and the main memory and the secondary memory is managed by the operating system. So operating system, these two will be in the control of operating system. Why? Because whenever this will be holding all the data. So I already told you, whenever we want to execute any program, that should be available in the main memory. So here comes the operating system, because these two are in the control of operating system. The operating system will be copying the data from this type to this type. I hope you all are you all are understanding. Now backup is nothing but if the registers, anything, if they want to get the data, no, they will be accessing the main cache memory, and cache memory will be getting the data from the main memory, and main memory will be getting the data from the disk. And in the disk, if you are not capable of storing, you can store that one in the pen drive, or you can store that the data in the CD, like that. So this is a backup data. If you want to have a backup data, then registers will be having a backup data in the cache, and cache will be having the backup data from the main memory, and main memory will be having the backup data from the disk, right? So this is about completely your main memory hierarchy. So you need to understand here what are the different types of memory and how the CPU is going to get the data from where, depending upon the speed. If we want, then we need to get the data from the cache memory or main memory, like that, right? I hope you all are clear with the memory hierarchy and how the data movement is between the different types of memories and all. Okay, so let us all meet in the next lecture. Until then, thank you all of you.